A large part of analytic geometry is based on the distances between points, right? So before we can really start talking about conic sections or any of the big concepts we're going to be covering, we have to have a formula. We have to have a way, given 2 points, to determine the distance between them. Right, so what I've got here is just kind of a little practical question that's going to motivate the calculations that we're doing. We're going to walk through the process that we use to do this, to find a distance using 2 specific points, and then we'll see how we can generalize this and turn it into a formula. All right, so let's see how we can graph this, and then add some things. We'll see how we can find this distance. So first, I need to graph these points, and obviously, I don't want to let one grid mark here be 1 unit, or I'd be over 100 units up to 212. So instead, let's let 1 grid mark be 50 units. Okay, so then 100 to 12 is over 2, and it's going to be up a little more than 4. So that's going to be 100, comma 212. Negative 85, 413. That's going to be over negative 85, a little less than 2, and up a little more than 8. So that's going to put it up here somewhere. And this is over negative 85, up 413. All right, so here's what I'm going to do. I'm going to add, no, for what do we want to know, right? We want to know this distance here. Let's call that D. That's what we're trying to find. All right, so now I'm going to add 2 more lines. I'm going to add a line going here through this bottom point parallel to the x-axis. Then I'm going to add another line here parallel to the y-axis and going through my second point. Right, so look at what I made here now, right? This is a right angle. And I love it when right angles show up in questions, because now I can use the Pythagorean theorem. Right, and to do that, I have to know this distance here and this distance here. Those are my 2 legs. Right, if I can find my legs, I plug them into the theorem's formula, and I should be home free. Right, well, how do we find these distances? Well, remember, to find the distance between 2 points, the horizontal distance is going to be 212 minus negative 85. Right, that's 212 plus 85. Oh, excuse me, it's not 212. I grabbed the y coordinate. This should be 100. 100 minus 85, which is 185. Then do the same thing up here with the y numbers. This distance is 413 minus 212, and that is 201. And that's all I need to know to answer my question. 201 squared plus 185 squared equals D squared. Right, and now it's just an arithmetic problem. This is 40,401 plus 34,225 equals D squared. Obviously, I worked these numbers out ahead of time. So this is 74,626 equals D squared. Then take the square root of both sides, and we get our answer. The square root of 74,626, which is about 273.17 units. No, nothing was feet or anything was specified, so we'll just call it units. Okay, so now we've done this with numbers, and that's great, right? What I want to do now is the same thing. What I want to do with variables. So I get a general formula that I can use, right? And I'm going to apply the same reasoning to make this happen. I'm going to pick 2 points here. Let's put x1 y1 down here. Doesn't matter what quadrant you put these in, which one gets to be higher and lower. The end result is going to be the same. I'm going to put my second point over here, x2, comma, y2. And what I want to find is this distance between them. Well, all I'm going to do is I'm going to walk through that exact same sequence of steps that I did when I was doing this with numbers. It's just going to have variables instead. So I'm going to add the same horizontal and vertical line. And I'm going to find the same distances. This height here is, these are the y's, right? Make sure I don't mess it up again. This is y2 minus y1. And this distance here, this is x2 minus x1. And now I can apply the Pythagorean theorem. D squared equals x2 minus x1 squared plus y2 minus y1 squared. And I want to be sure if you're taking notes that you write this down, because sometimes we will use this version of the formula. So sometimes it's convenient to have it this way. But for purposes of answering the question, remember I really wanted to find D. So to find D, we take the square root of both sides, and I get the square root of x2 minus x1 squared plus y2 minus y1 squared. And that is my distance formula. All right, that's my formula for finding the distance between 2 points. And just kind of, especially when things are new, it's helpful to have tools for remembering these things. What do? We take the distance, the difference of the x values and the difference of the y values, square them, add them together. Right? That's all this formula is saying to do. All right, so now that we've got the formula in hand, in the next lecture, we're going to look at some specific examples, questions that we can answer using this formula, and then from there we'll move on and start talking about our first conic section.